We will now talk about the concept of present value. Let's say that 1 year from today, you will receive a cash flow of 110. The question is, what is the value of that 110 today? To solve this, you need an interest rate. Let's say the interest rate is 10%. The present value at time 0, which is now, then becomes 110 divided by 1 plus the interest rate, which is 0.1. You solve this and you will get 100. What this means is that 110 1 year from today has a present value of 100. In other words, you would be indifferent between 100 today and 110 1 year from today. The formula, as you have seen over here, is fairly straightforward. The present value at time 0 is equal to the future value at time 1, which was 110, divided by 1 plus the interest rate raised to the power of 1. What if you were to receive money at the end of 2 years? So if you are to receive 121 at the end of 2 years, then what is the present value? Then instead of writing FV1, we would write future value at the end of year 2 divided by 1 plus the interest rate raised to the power of 2. So if we are to write this in general form, then this is what we would have. And I'll just write this in a simpler form. The present value is equal to the future value at time n divided by 1 plus the interest rate raised to the power of n. Notice also the relationship between this formula and what you have seen earlier. The earlier formula, where we were talking about future value, was the following. The future value at time n was equal to the present value at time 0 into 1 plus r to the power of n. And you can simply algebraically rewrite this as present value at time 0 is equal to future value at time n divided by 1 plus r to the power of n. So that then is the formula, and the concept, as I said before, is simply that we need to determine the present value of a certain cash flow that you will receive in the future, and we then use the interest rate to discount back. We can say that for a given discount rate, the further in the future the amount is to be received, the smaller the amount's present value. So if you are to receive $110 at the end of year 1 versus $110 at the end of year 2, where will the present value be higher? Clearly, the present value will be higher in this case, assuming, of course, that the discount rate is the same in both cases. And you can see why. In this particular case, the present value is given by 110 over 1 plus 0.1 to the power of 1, whereas in the second case, the present value is 110 divided by 1 plus 0.1 squared. In the second scenario, the denominator is larger, therefore the present value will be lower. That is the mathematical explanation. The intuitive explanation is that clearly receiving a certain amount of money sooner is better than receiving the same amount of money at a later point in time. The next point that you should also be aware of is that holding time constant, the larger the discount rate, the smaller the present value of a future amount. So let's say that you are receiving at the end of year 1 $110 and the discount rate is 10%, versus another scenario where at the end of year 1 you are again receiving 110, but here the discount rate is 20%. Clearly the present value over here is going to be higher because we are discounting at a lower rate. In this particular case, the present value will be equal to 110 divided by 1.1, whereas in the second scenario, the present value will be 110 divided by 1.2. So again, you need to be on top of this. Let's see if you can do this practice problem now. Using the formula, here is what you should do. The contract will pay 600,000 after 8 years. So that's the future value. The present value is equal to the future value divided by 1 plus r to the power of n. And if we plug in, the future value is 600,000 divided by 1 plus r. The interest rate is 5%, so we put 1 plus 0.05, which is 1.05, raised to the power of number of periods, which is 8, and that should give you the answer, which is 406,104. Using the time value of money function on the calculator, what you simply do is the following. You plug in n is equal to 8. The interest rate is equal to 5. Notice that here we put in the percentage as opposed to in the formula where we use the decimal. And then the PV is what we are going to compute. The payment in this particular case is equal to 0. And the future value you plug in as 600,000. And when you do this on the calculator, you should get the same answer. Let's try this problem now. For a problem like this, it is useful to first draw the timeline. The security will pay $1 million in 12 years. So if this is time 0, this is time 12, this is where we are getting $1 million. College will begin 3 years from now. So that's at the end of 3 years. Notice that 3 years from now means end of 3 years. On the timeline, wherever you see the number, that number represents the end of that year. This is end of year 3. So what is the present value of 1 million at this point in time? We need to discount this back. How many periods? Between the end of year 3 and the end of year 12, we have 9 years. So this needs to be discounted back 9 years. And again, you can do this on the calculator or you can do this using the formula. The present value at the end of year 3 over here is equal to 1 million divided by 1.075 to the power of 9. And the answer that should give you is 521,583. On the calculator, you simply plug in n is equal to 9. The interest rate is equal to 7.5. The PV is what you are going to compute. Payment 0 and FV is equal to 1 million. Next question. So Orlando is a manager at an Australian pension fund. 5 years from today, he wants a lump sum amount of 40,000. Given that the current interest rate is 4% a year but compounded monthly, how much should he invest today? This is similar to what we have seen before, but the compounding now is monthly. So if he is going to receive, or he wants to receive 40,000, this is 5 years from today, but we are doing monthly compounding. So in terms of number of periods, we have at this point 5 into 12, which is 60. Between time 0 and end of year 5, we have 60 periods, and the interest rate for each period is going to be 4% divided by 12. So in the calculator, we plug in 4 over 12 as the interest rate. The number of periods is equal to 60, which is what we've calculated here. The present value is what we need to find out. The payment is equal to 0. The future value is 40,000. You plug in the numbers, compute the present value, and you should get 32,760. Let us now talk about the present value of a series of cash flows. And in this segment, we will go over these scenarios. First, let's calculate the present value of an ordinary annuity. And as you've seen before, an ordinary annuity means that the first cash flow will occur at the end of the current period. So if you are here at time 0, an ordinary annuity means that the first cash flow, which in this case is 10, will occur at the end of year 1 or end of period 1. When we say n is equal to 5, that means that this payment will happen 5 times, and the interest rate that is given is 5%. The brute force way of calculating the present value is to simply take each cash flow and compute the present value. So for the first cash flow, the present value will be 10 divided by 1.1. For this second one, it will be 10 divided by 1.1 squared. So if you simply take the present value of every cash flow and then add up all these numbers, what you should end up with is 43.29. And I have just done this for illustration to demonstrate what actually is going on. Clearly on the exam, if you do something like this, it will take too long. So this is not the recommended way of solving a problem like this. Another strategy you can use is to apply this formula. What we do here is again recognize that we have the same annuity, 10, 10, 10, 10 and 10. The present value at time 0 is given by this formula, which I will rewrite for you. So A is the annuity amount, which is 10, multiplied by 1 minus 1 over 1 plus r to the power of n. R is the interest rate in decimal. N is the number of periods, which in this case is 5. And then we take this entire amount and divide by the interest rate. If we plug in the numbers, A is 10. The interest rate that we plug in is going to be 0.05. N will be 5, and here also 0.05. And when you solve this, what you will get is the same answer that we had from the previous slide, which is 43.29. This expression in brackets is called the present. This expression in brackets is called the present value factor for the annuity. While this formula is good to know, but it is not necessary that you memorize this formula, because in the real world, problems such as this will be solved on a computer. In your exam, a problem such as this should be solved using the calculator. So let us make sure we understand how to solve this using a calculator. It is the same annuity, and on the calculator you use the time value of money function. So you plug in n is equal to 5. The interest rate is also 5. The present value is what you'll be computing. The payment is 10, and the future value is 0. When you plug in these numbers, the answer that you should get is 43.29. So in essence, we have gone over 3 different methods for coming up with the present value at time 0 for this annuity. The fastest, most efficient method is the calculator method, and that is the one you need to use on the exam. Moving now to the annuity due. With the annuity due, the first payment is received at the start of the first period. So if we say that we have an annuity due with A equal to 10, that means that the first payment is received at time 0. And then if we are told that n is 5, that means that this payment will be received 5 times. So the final payment is end of year 4, which is the same as the start of year 5. Again, to calculate the present value, the brute force method would be to take the present value of each cash flow. The present value of 10 is 10. You can then compute the present value of all subsequent cash flows, and then add up these numbers to come up with the present value of the annuity due. Notice that with the annuity due, you are receiving money faster, which means that the present value of annuity due is going to be greater than the present value of ordinary annuity. You can also come up with the present value of an annuity due using the formula, and take a look at this formula. I will rewrite it for you. A multiplied by 1 minus 1 over 1 plus r to the power of n, and this entire amount divided by the interest rate, and then we multiply this expression by 1 plus r. This expression is the same as what you saw earlier. In other words, this is the present value for an ordinary annuity. And see what's going on here. If you have payments at the start of every period, then the ordinary annuity formula gives you the present value one period before the first payment. So if there is any such thing as a -1, the ordinary annuity formula is simply giving you the number over here. And then that number that we arrive at using the ordinary annuity formula needs to be taken forward one period. That is why we multiply by 1 plus r. So again, you can simply plug in the numbers. A is 10, r is 0.05, n is 5, and again 0.05 and 0.05. You can plug in these numbers and get the answer for the present value of the annuity. And the answer that you should get is 45.46. Annuity due using the calculator. The point is that you first have to put the calculator into begin mode. The default for the calculator is that it is in end mode. In other words, when you simply plug in numbers, the calculator assumes that the cash flows are happening at the end of each period. When you press these buttons on the calculator, second begin, which is right here, and then second set, that puts the calculator into begin mode. So notice when you do this on the calculator, it will then say begin here on your screen. This means that the calculator will now assume that any cash flow that you enter is really happening at the start of each period. Second quit, to simply put the calculator back into standard mode. You clear the time value of money, and then 5n, so we are saying that we have 5 periods. The interest rate is 5, the payment is 10, future value is 0, and then you compute the present value. And what you should get here is 45.46, which is the same answer that you should have gotten on the previous calculation. And notice also that 45.46 is equal to the present value from the ordinary annuity, which is 43.29 multiplied by 1.05. Once you are done with the calculation and you have come up with the present value, then you need to change your calculator back into end mode, because most questions will be solved assuming payments are at the end of the period. So you need to put the calculator back in end mode. If you do not do this, then all future calculations will be performed in begin mode. And then again, second quit to get back into standard calculator mode. Moving now to the present value of a perpetuity, and if you recall, a perpetuity is a never-ending series of equal cash flows. So let's say we have a really simple perpetuity where you receive $10 at the end of every year forever, and let's say that the discount rate is equal to 0.05 or 5%. The present value of this cash flow is simply given by the amount, which is 10, divided by the discount rate, which is 0.05. So the answer here is 10 over 0.05, which is 200. Keep in mind that the present value of 200 is one period before the first cash flow. The first cash flow is happening at time period 1. The present value is one period before the first cash flow. Many people incorrectly show the present value of 200 at the same time as the first cash flow, but again, that is incorrect. You need to show the present value, or the present value is one period before the first cash flow. So let's look at another example. If you invest $100 and get 5% forever, what is the cash flow? So if at time t equal to 0 you invest $100 and get 5%, then every year you will get $5. So notice then, $5 every year forever, where the first payment is received at the end of year 1, is the same as having $100 today, assuming a 5% rate. So look at the calculation here. The rate of 5%, 0.05, is equal to the $5 which you get at the end of every year divided by the investment. So if we write this as symbols, the rate is equal to the amount, 5 is the amount, divided by the investment amount, which is the present value. So this expression has simply been rewritten to come up with this. Using very basic algebra, you can then see that the present value is equal to A over R. So that is where this expression comes from. Present values indexed at times other than t equal 0. An annuity or perpetuity beginning sometime in the future can be expressed in present value terms one period prior to the first payment. Let us look at a simple example here. Let's say that I offer you a cash flow which starts at the end of year 5, and this goes on forever. So I'll give you $10 at the end of year 5, end of year 6, and so on forever. So this is a perpetuity which is starting at the end of year 5. The question is, when we use the annuity formula, or actually in this case the perpetuity formula, the present value is equal to the amount A, or the payment, which is 10, divided by the discount rate. Let's say that our discount rate now is 0.1 or 10%. So the present value is 10 over 0.1, which is 100. This present value of 100 is one period before the first cash flow. So what we can say is, for this entire perpetuity, which starts at the end of year 5, the present value will be one period earlier. So the present value will be here, and that present value is equal to 100. In other words, present value at the end of year 4 is equal to 10 over 0.1, where the first payment of 10 is happening at the end of year 5. So what then is the present value at time 0? That will simply be the discounted value of 100. So present value at time 0 will be equal to 100 discounted back to time 0, which would be 100 divided by 1.1 to the power of 4. Power of 4 because this 100 is being taken back 4 periods. Let us see if you can solve this problem now. The first payment will be received at t equal to 4. That is right here. And then this payment will be received at the end of every year forever. So this is a perpetuity. The present value of the perpetuity given a discount rate of 10% would be 100 divided by 0.1, which is 1000. So this present value is one period before. So the present value at time 3 is equal to 1000. This value of 1000 is equivalent to all these cash flows which start at the end of year 4. We want to know what is the present value at time 0. So that is simply going to be 1000 discounted back 3 periods. So that would be 1000 divided by 1.1 to the power of 3. If you do the calculation, you should get 751.31. This can also be done using the calculator, where the future value is equal to 1000, the payment is 0, the interest rate is 10, and you compute the present value. Next, let's look at the present value of a series of unequal cash flows. All we do here is find the present value of each individual cash flow and then sum up the numbers. So if you have $100 here, 200 and 300, and the discount rate is 10%, you find the present value of 100, present value of the second number, present value of the third number, and then all these items are added up to come up with the present value. Let's do this example. The first thing you should do here is create your timeline. So you have 5 time periods and 5 payments happening at the end of each of those periods. The payments are 50, 100, 150, 200 and 250. You take each payment and discount back at 9% and then add up all these numbers. The answer that you should get is 550. This is a long-winded way of solving the problem. In the next reading, I will show you how to use the calculator to solve this problem. We now come to the final section where we will apply some of the concepts that we have learnt. Solving for interest rates and growth rates. Let's take a very simple example. Say you have $100 today, which you deposit, $100 at time 0, and this $100 grows to 121 in 2 years. What is the interest rate, given that this growth took place in 2 years? You can apply the simple formulas that you have learnt. So one way of doing this is to say that 100 multiplied by 1 plus the interest rate, which is unknown, so let's say that is R, to the power of 2, because we have 2 years, is equal to 121. You solve for R, and essentially what you will get is R is equal to 0.1. You could also have just seen the fact that the return here is 10%, because 100 would grow to 110, and then this would further compound to 121. Using a calculator, what you could do is the following. Present value equal to 100, future value equal to 121, and you need to hit the plus minus and make this negative. When the calculator does compounding, the future value and present value have to have opposite signs, because the way the calculator looks at it, 100 is going in one direction, perhaps into a project, and 121 is coming out. Since the direction of cash flow is different, therefore the sign that we give has to be different for the present value and future value. The number of periods is 2. The interest rate is what we compute, and the payment in this case is 0 because there is no cash flow in between. When you compute the interest rate, you will get 10%, just as what you get when you use the formula. Obviously, what I have done here is a straightforward example, but you can imagine that the numbers can be a whole lot more complicated, and clearly it makes sense to solve problems like this using the calculator. Let us now look at another problem. The population of a small town is 100,000 on 1 January 2000. On 31st December 2001, the population is 121,000. What is the growth rate? Notice that we have growth over 2 years. From 1 January 2000 till 31st December 2001 is 2 years. So like this problem, the growth is over 2 years. Initially, the population is 100,000, and then after 2 years, it's 121,000. So even though we are talking about population growth rate rather than interest rate, the calculation is exactly the same. You can see that again the interest rate is going to be 10%, the growth rate is going to be 10%, which is the same as 0.1. Given that the calculation is exactly the same, we can apply the calculator method here, plugging in 100,000 for the present value minus 121,000 for the future value, n equal to 2, payment 0, and compute the interest rate. The interest rate here would really be the growth rate, which will be 10%. The larger point is that anytime you have compounding and compound growth, we can use the calculator function. Let's look at another scenario now. You invest 900 today, so the present value is minus 900. Receive a 100 coupon payment at the end of every year for 5 years. This means that the payment is equal to 100, n is equal to 5 because the payment is being received for 5 years. In addition, you receive 1,000 at the end of year 5. That means that the future value is equal to 1,000. The question is, what is the interest rate? So the I is what you are supposed to compute. Notice that I had a different sign for the present value and future value. The way we can think of this is an investment is a negative number, so money going in, the payments, the coupon payments in this case are received, so that's plus, and the future value is also received, so that's plus. We could also get the same answer by using a positive number for present value, but then we would have to use negative numbers for payment and future value. Solving for the number of periods. You invest 2,500. How many years will it take to triple the amount given that the interest rate is 6% per annum compounded annually? Using the calculator method, all we need to do is the following. Present value is 2,500. Future value needs to be the opposite sign. The number needs to triple. So future value is 7,500 minus. We are told that the interest rate is 6%. Payment is equal to 0 because there is no cash flow in between, and n is what we compute. If you plug these numbers, what you should get is 18.85 years. Using the formula, you do the following. 2,500 into 1.06, that's 1 plus the interest rate, raised to the power of n is equal to 7,500, and then use simple algebra. 2,500 comes down over here, so this becomes 3. You have 1.06 to the power of n is equal to 3. Take the log of both sides, so log of 1.06 to the power of n is equal to log of 3. Using your log maths, hopefully you remember that this exponent comes down over here, so n times log of 1.06 is equal to log of 3, so n is equal to log of 3 over log of 1.06. On your calculator, you will see the ln button on the left, so you can just plug in ln 3 divided by ln 1.06, and here again you should get 18.85. Next, solving for the size of annuity payments. Read this problem and try to solve it before you listen to my explanation. The first thing you should do is figure out how much is the effective loan. Given that Freddie is paying 15%, that means that the loan amount is 0.85 into 42,000. This is the amount that he's paying over time. So the numbers you plug in are present value 35,700 and 12 periods because we have monthly compounding. So one period is 1 month. The interest rate per month is 8% for the year divided by 12. The future value is 0 and you compute your payment, and here is the answer that you should get. Present value and future value equivalence. This is a straightforward point which should be obvious given what we have talked about so far, but in any case we will go over the concept. Let's say you have an ordinary annuity with A equal to 10, R 5%, N 5, and if you compute the present value you will get 43.29. A lump sum can be considered equivalent to an annuity. So a lump sum amount of 43.29 at time 0 is the same or is equivalent to this annuity. So if somebody were to give you a choice between 43.29 today versus an annuity that looks like this, you would be indifferent assuming a rate of 5%. So this annuity and this lump sum are equivalent. Also, an annuity can be considered equivalent to a future value. If you take this annuity and compute the future value over here, you will get 55.26. What that means is between an annuity shown here and a value of 55.26 at time 5, you would be indifferent. So that means that 43.29 and 55.26, so this money at the end of 5 years, 43.29 at time 0, these two numbers are also equivalent given a rate of 5%. So a lump sum can be considered equivalent to a future value. The cash flow additivity principle, this is a complicated sounding phrase for a straightforward concept. Amounts of money indexed at the same point in time are additive. In other words, if you have 100 at the end of 1 year, 100 at the end of 2 years, and 100 at the end of 3 years, you cannot simply add these three numbers. What you need to do is take each of these numbers and bring them back to a particular point in time. Let's say that we find the present value at time 0 for each of these cash flows. These present values that are all indexed to time 0 can be added. So that is the additivity principle. Amounts of money indexed at the same point in time, here that point in time is time 0, are additive. So that brings us to the end of this reading. We talked about the interpretations of interest rates, and we talked about how an investor can think of interest rates as a sum of multiple components. We then talked about future value, the concept of compounding. Then we went over the present value concept and the fact that we can discount a future value to come up with present value. And these three concepts can be linked using a very simple relationship. Future value at time n is equal to present value into 1 plus the interest rate to the power of n. And this can be rearranged and expressed in terms of present value. We then did several problems where we solved for rates, number of periods, size of annuity payments, and so on. My suggestion now is that you review the learning objectives in the curriculum and make sure that you understand them. The examples and practice problems in the curriculum are fairly difficult. If you have trouble with them, that's okay, because most of these examples and practice problems are a little bit harder than what you are likely to see on the exam. But still, it would be useful if you try to do them and go over the solutions. For this particular reading, I think it would be useful to get as many practice questions from other sources. For example, IFT will be releasing some questions. You could get questions from Schwezer, FinQuiz, and so on. So the more questions you do on the subject, the better, because if you practice more, you will understand the concepts a whole lot better. So that is it. Good luck with your studies.